Have you ever looked up at the night sky and felt a sense of wonder? It's beautiful, vast, and mostly peaceful. But what if I told you that the universe harbors a weapon so powerful it could wipe out life on Earth in an instant, from thousands of light years away? It's not science fiction. It's called a gamma ray burst, or GRB for short. Today, we're going to explore a terrifying but fascinating scenario. What if Earth was hit by a gamma ray burst? So, what exactly is Imagine a star, much more massive than our sun, running out of fuel. Its core collapses under its own immense gravity, forming a black hole. As this happens, the star's outer layers are blasted into space in a supernova. But for some special, rapidly spinning stars, something even more spectacular occurs. The newly formed black hole shoots out to incredibly powerful, focused jets of energy from its poles, traveling at nearly the speed of light. These jets are packed with gamma rays, the most energetic form of light in the universe. If you were to witness one, even from a safe distance, it would briefly outshine all the other stars in its galaxy combined. They are, without a doubt, the universe's deadliest explosions. Now, let's set the stage for our cosmic disaster. Imagine a massive star, about 6,500 light-years away from us, in a distant arm of our own Milky Way galaxy. For millions of years, it's been just another point of light in our sky. But today, its life is over. It collapses, forms a black hole, and unleashes two brilliant jets of gamma rays. By a stroke of unbelievably bad luck, one of those jets is aimed directly at our little blue planet. What happens next? Well, for the first 6,500 years after the explosion, absolutely nothing. The light and radiation from the burst have to travel across that vast expanse of space to reach us. On Earth, life continues as normal. Civilizations rise and fall. History unfolds. And no one has any idea of the cosmic bullet speeding toward us. Then, the moment arrives. The first sign wouldn't be a giant explosion in the sky. It would be a silent, imperceptibly flash. Gamma rays and other high-energy particles would slam into our upper atmosphere. The sky would suddenly light up with an eerie, blue-white glow, brighter than the sun, as these particles interact with the air. This light show, known as Cherenkov radiation, would be visible even on the day side of the planet. But this beautiful, terrifying spectacle is just the beginning. The real damage starts in our atmosphere. The intense flood of gamma rays would tear apart nitrogen and oxygen molecules. This chemical chaos would create huge amounts of nitrogen oxides. It's the same stuff that creates smog and acid rain, but on a planetary scale. These reddish-brown clouds would blanket the globe, blocking out a significant portion of sunlight. The planet would be plunged into a dim, cosmic twilight. The most immediate and devastating effect would be the destruction of our ozone layer. Scientists estimate that a nearby GRB could obliterate up to half of the ozone layer globally, and almost all of it in the hemisphere facing the burst. The ozone layer is our planet's natural sunscreen, protecting all life from the sun's harmful ultraviolet, or UV, radiation. Without it, we're completely exposed. For anyone unlucky enough to be on the side of the Earth facing the burst, the initial flash of radiation could be lethal, but the long-term effects are even more terrifying. With the ozone shield gone, the sun becomes our enemy. Lethal levels of UVB radiation would pour down, scorching the surface of the planet. On land, Plants would wither and die. Photosynthesis would grind to a halt, not only from the deadly UV rays, but also from the initial dimming of the sun caused by the atmospheric smog. This would trigger a catastrophic collapse of the food chain from the bottom up. Crops would fail worldwide, leading to global famine on a scale we can't even imagine. Animals exposed to the unfiltered sunlight would suffer severe burns and cancers. The oceans wouldn't be a safe haven either. Plankton and algae, which form the base of the marine food web and produce a huge portion of our oxygen, live near the surface. The intense UV radiation would sterilize the upper layers of the oceans, wiping them out. This would cause a mass extinction event in the seas, and our planet's oxygen supply would start to dwindle. The nitrogen oxides created by the GRB would also lead to another problem. Acid rain. A corrosive, planet-wide rain would fall for weeks, poisoning soil, rivers, and lakes, and further devastating any life that managed to survive the initial onslaught of radiation. After the initial crisis, the planet would enter a new, harsh phase. The global dimming from the smog would cause temperatures to plummet, potentially triggering a rapid onset ice age. So we'd be dealing with freezing temperatures, acid rain, and lethal UV radiation all at once. It is a recipe for a mass extinction event that would rival the one that wiped out the dinosaurs. Could humanity survive? It's a grim picture. Surface life would be almost impossible. Our only hope would be to move underground or deep into the oceans to shield ourselves from the UV radiation. We'd need to build self-sufficient bunkers, capable of producing food and recycling air and water for generations. But building such infrastructure on a global scale before society completely collapses would be an immense challenge. Perhaps a small fraction of humanity could survive in these deep shelters, waiting for the atmosphere to slowly recover. It would take decades, maybe even centuries, for the ozone layer to heal itself. For those survivors, emerging from their shelters would be like stepping onto an alien world. The planet's biosphere would be fundamentally changed. Many species would be gone forever. The long process of rebuilding civilization would have to begin on a scarred and wounded Earth. Now, before you start packing your bags for an underground bunker, let's take a deep breath. What are the actual chances of this happening? The good news is, they're incredibly small. First, a star has to be the right type of massive, rapidly rotating Wolf-Rayet star. Second, it has to be close enough to harm us, probably within our own galaxy. And third, and most importantly, its rotational axis has to be pointed directly at us. These jets are highly focused, like a laser beam. If we're not in the direct line of fire, we're safe. Astronomers estimate that a dangerous GRB might happen in our galaxy only once every few 100,000 years. And even 10. The odds of it being aimed at us are tiny. So, while it's the most powerful explosion in the universe, it's also one of the rarest events to be in the crosshairs of. For now, the asteroid that killed the dinosaurs remains a much more likely, though still rare, type of cosmic threat. So, the next time you look up at the stars, you can still feel that sense of wonder. The universe is a place of incredible power and extreme events, but it's also unimaginably vast. The same vastness that makes these events possible is also what protects us. Gamma-ray bursts are a humbling reminder of our fragile place in the cosmos, but they aren't something to lose sleep over. Thanks for joining us on this cosmic journey into destruction. If you enjoyed this video and want to explore more mind-bending what-if scenarios, be sure to hit that like button and subscribe. Let us know in the comments what cosmic catastrophe you'd like us to tackle next. Until next time, stay curious.